We're going to look at vectors. Vectors are a quantity that have both magnitude and direction. We're going to start off representing vectors in different dimensions using the list notation. So a two-dimensional vector in list notation will have two elements. A three-dimensional vector will have three elements, and a four-dimensional vector will have four elements, and an n-dimensional vector will have n elements. So that's how we represent it as a list, but we can also represent vectors in a graphical way, and we're going to stick to two dimensions for this. So let's draw our axes for representing this graphically. So we have our x-axis and our y-axis here. We're going to represent the vector 3, 4, which would be something along the lines like this. And just make sure we're clear where we're going to mark this. So that's 3 here, and along the y-axis it's 4 here. So I mentioned that vectors have both magnitude and direction. Well, the magnitude is the length of this line here, and the direction is the angle of the vector from the horizontal here. Let's have a look now how we calculate those magnitude and direction based on the vector. So this vector here, just to be clear, it's 3, 4 there. Okay, so to calculate the magnitude, well, this is an application of Pythagoras, so it's square root of x squared plus y squared. So the magnitude is essentially the hypotenuse of the triangle there. And then the angle here, the direction, it's the angle from the horizontal. So the direction is equal to the inverse of tan y over x. So let's plug those values now into these expressions. So to calculate the magnitude then, that's x squared, so that's 3 squared, plus y squared, so that's 4 squared, square rooted, which gives us 5. So that's our magnitude. And then the direction is inverse of tan y, which is 4 over 3, and that gives us an angle of 53.1 degrees.